Hello, it's me again. So, last reaction we're going to cover in this chapter is going to be the Robinson annulation reaction. So, the Robinson annulation reaction, as mentioned at the end of my last video, is one of the more difficult reactions to go over because it's a two-step process that combines both a Michael reaction with the intermolecular aldol reaction. So, you have to do both those reactions at once. Well, you do them sequentially. You'll do the Michael and then you'll do the intermolecular aldol reaction. But at the very end, it can be complicated if you have a complicated molecule. So what I'm going to start off is one of the more complicated ones, but then we'll go in the text and work some more of the simpler ones. Okay. So let's go ahead and look at an example. So I start off with something that has an alpha beta unsaturated aldehyde or ketone. I've got a lot of other things attached here as well, but this is just going to be the base part here. And I've got something with a dicarbonyl compound. So first step is a Michael type reaction. And so here's my dicarbonyl compound, takes off the proton in between, adds to the beta position here. Okay, so let's go ahead and draw that. So you kind of see that there. So I just, at this beta position here, I just attached that 5-member ring there. Okay. So now I'm going to have an intermolecular aldol reaction. I drew it this way on purpose to show you the intermolecular aldol reaction. And so if I look at this carbon, and I can go 1, 2, 3, 4, 5, I can make a 5-member ring from that carbon. I think I left out a carbon somewhere. Okay, right here. So, mistake I made when I attached it here. So here's my alpha position, here's my beta position. So I left off a carbon there. So I had that alpha beta, but then I should have had another bond going down here, so I missed one of my carbons. That all fell on the screen. Okay, so here's 1, 2, 3, 4, 5, 6. So I can form a 6-member ring here. And so if I treat this with the base, I can take off the alpha proton and it attaches there. So let's just go ahead and draw that out. So I formed a 6-member ring. Here's my 1, 2, 3, 4, 5, 6. So I have 2 carbons there. 2, I have a carbonyl. 3, 4, 5. Between 5 and 6, I have this 5-member ring. Right, I have 1, 2, 3 carbons in between them. 1, 2, 3 carbons in between them. So 5, I have that methyl group. I have that carbonyl, CH2. So I attached here and made my O minus, or you can say an OH. Now, if it underwent condensation at that point, I can just make that into a double bond. Okay, and that's actually the final product of my reaction. That's the Robinson annulation reaction. Okay, so that's more of a complicated example. So let's look at some of the examples in the book that's not quite that complicated because I won't have all this other stuff attached to it, and we'll break it down a little simpler then. So what I'm going to do is I'm going to work this one, but it's also one of the problems in your book. So it says, what product would you expect from Robinson annulation reaction of 2-methyl 1,3-cyclopentane with 3-pentene 2-on? If I did this on an exam, I'd probably say we're Robinson annulation to try to give you a hint on how you would work it. So, first step is that Michael addition. So I have a dicarbonyl compound here. Okay. So I'm going to take that alpha position in between, connect it to the beta position here. Now, if I look at this molecule, so here's the alpha position, okay, to one of my carbonyls, and I go 1, 2, 3, 4, 5, 6. I can form a 6-membered ring. And so I did the Michael addition part. Now I'm going to do the intermolecular aldol part. I'm just going to draw out that. I know it forms a 6-membered ring. Okay, so I drew all that out. So between, let's go ahead and number 1, 2, 3, 4, 5, 6. So between 5 and 6 here, okay, I have a 5-membered ring. And you can draw this any way. So I drew it here, but next to 5, I have a carbonyl and a methyl group. So 5, I have a methyl group attached next to a carbonyl. Probably should have numbered it a little bit different to be less confusing. Let's do that. You could have continued on the way I was doing it, but it just wouldn't have looked the same here. So if I just did this 6, 5, 4, 3, 2, 1. Okay, just to kind of keep the 6 and the 5s on the same sides here. So between 5 and 6, I have this 5-membered ring. So at 5, I have a methyl group. And then right adjacent to that, I have a carbonyl. Okay. 4 is a CH2, 3 is a CH2, 2 is a C-double-bond-O. Okay. 1, this is my alpha proton that attached, and it made 6 an OH group. But then if I drew the condensation part of that, I make that into a double bond. And so that would be my Robinson annulation product, because you always get the condensation product too. And so that's one thing you kind of have to look for, but you do them separately. You do, okay, I'll do the Michael addition first, and then I'll do my intermolecular aldol reaction and draw it out from there. But like I said, it's one of the more difficult reactions that we'll see all year. So let's go ahead and look at the next one. Now this one I'm given a product, and so I'm going to be working backwards from it. Okay, so I want to work backwards. So if I had a dicarbonyl compound someplace, so if I'm looking at this one, if I see my dicarbonyl is 6-membered ring there, here's a 6-membered ring. So this could be my dicarbonyl portion, right? And so I could have, you always end up with this conjugated ring here. And so if I took that apart, and this was my dicarbonyl compound, this would have been my OH group. So let's just work backwards. So I'm going to take off that double bond and put an OH group there. Remember, I always form that double bond. So I know that attached to that position. So this must be my alpha position that attached to that carbonyl. So this is where my C double bond O was before my intermolecular aldol reaction. Okay. And so now I can take off this part. This is the position in between my 2 carbonyls. So now I can take that off. And I know that attaches that Michael addition. So that attaches to the beta position of my alpha beta unsaturated ketone. So now I have my 2 pieces. I just took it apart. Drawn differently, I'd have C double bond O, C double bond O. Methyl group in between. This would be 5 carbons. The double bond there. There are my 2 compounds. So Michael addition, then intermolecular aldol reaction. Okay. So that is the Robinson annulation reaction. So that will do it for chapter 23. And so the next video will be starting chapter 24. See you then.